This lesson is going to be the first of a couple covering quadratic equations, and I thought it best to split up so we're not cramming all of these different ways to solve into a single video. But let's begin. Now, previously we had looked at linear equations, which again, those are in the form, just as an example, say, all right, let's try that again. So, say 3x plus 2 equals 11. So that's just a basic linear equation right there. And also called, as we said, first degree equations. Now, quadratic, on the other hand, are what we would call second degree equations. And might look something like, so now we'll have our highest exponent will be a 2 now in a quadratic equation. So it might look something like this. Okay. So note the difference between a linear and then now this would be an example of a quadratic, all right? Those equations where the highest exponent is a 2 now. And the general form for a quadratic equation looks like ax squared plus bx plus c equals 0. So let's remember that going forward. So this is the general form for a quadratic equation. So just like in this one, we have our a, which is actually just a 1, and then this is our b, and then that is our c. So the general form where a, b, and c are real numbers, and then a cannot be 0. So one method for solving quadratic equations is to use factoring. So that is going to be the first method that we look at, is factoring. And to do this, we'll need to apply what's called the zero product principle. All right. So this is all going to be now under factoring. Let's get some space here. All right. So this is our first method. We'll be going over, we'll do a couple in this video, and then we'll do a couple in another one. But these are all going to be different methods you can use for solving quadratic equations. So first, factoring. And the key with factoring is, like I said, the key will be what's called the zero product principle. And what this states is that if the product of two algebraic expressions is 0, then at least one of the factors is equal to 0. So for instance, so it tells us that if a times b equals 0, so if the product of two algebraic expressions, in this case a and b, is equal to 0, then at least one of the factors is equal to 0. All right? So in plain terms, this is what the zero product principle is telling us. If we have two algebraic expressions and the product is equal to 0, then at least one of the factors must be equal to 0. So if we had to put some numbers and some x variables to it, if we had x plus 4 and x minus 7, and that was equal to 0. All right, so applying the zero product principle, we have our two algebraic expressions. They're equal to 0. So all it's telling us is, and again, key here, it's equal to, we have 0 on the right side. That's part of being able to apply this. We have it equal to 0. We have a 0 over here. So we can solve it using this zero product principle, and we can take each individual part and set it equal to 0. So x plus 4 equal to 0 and x minus 7 equal to 0. So essentially what the zero product principle allows us to do, we can go from when we're here and we can go to here in order to solve and figure out what our solutions are. So obviously if we solve both of these, if we subtract the 4 over, then we have x equal to -4, and then add the 7, we have x equal to 7. So in this case, we would have two solutions by applying that principle. So again, if you just remember, that's the basic of what it's allowing us to do. Go from here, go from this point, to go from this point, provided that, again, we have 0 on the right side. So let's take a look at an example here. So we're going to be given a quadratic equation. So our highest power is going to be a 2. So we're going to have, we'll have x squared plus 4x equals 45. Okay? So we have a quadratic equation, and we're going to solve this one, figure out what x is by factoring. Now in this case, the first thing we want to do is, let's break this down. So the first step, we don't have it in the general form. That would be the first thing that we want to do, is let's rewrite it in the general form, which is, again, ax squared plus bx plus c equals 0. That's the general form. So first thing let's do, let's rewrite it in that. So all we have to do is we just need to subtract the 45 over. All right. Get that 45 over. So now we have 0 on the right side. And then over here we have now x squared plus 4x, and now minus 45 equal to, and then we just have 0. All right. All that's left over then on the right is 0. So now we can proceed. We've got it in the general form. Make it easier for us to work with. So again, this is our a, which is just 1. Our leading coefficient is just the 1. The 4, that's our b, and then c is technically -45, because we have that minus there. So now that we have it in the general form, next step, we can factor it. All right, and I always like to start out just like, get my x with my parentheses. Okay. we're still equal to 0. Okay, this is how I always just like to start it off, just like when I'm factoring. Set it up just like this. Okay, so now we are looking for factors of 45, negative 45 to be specific, that add together to give us 4. All right, that's how we come up with our numbers to put into the parentheses. We're looking for factors of 45. All right, 2 factors of 45 that add to 4. So let's start with, obviously we have 1 in 45, but that's going to get us nowhere close to adding to 4. We'd have, let's see, 3 times 15. That would get us to 45. But again, that, no matter what way you slice it, that's not going to get us close to 4. And then let's see, we have 5 times 9. Okay, this could work for us. 5 and 9, because we have to remember, again, our C is at technically negative 45. So one of these can be a negative. So let's try, if we did, well, we'll make this a negative 5, so that'll be x minus 5, and then this will be a positive 9. So x plus 9, x minus 5. And that should work for us, because because we know if we made that a negative 5, and then we had a 9, that gets us to a negative 45, and then negative 5 plus 9 would get us to a positive 4. So this should work, but it never hurts to just check your work. So if we FOIL this, we'd get x squared minus 5x plus 9x, and then minus 45. And then when we combine those like terms there, we'd end up with negative 5 plus 9 gets us to positive 4. So it looks like that will definitely work. So these are going to be our factors: x plus 9, x minus 5. So let's proceed from there. So we've got this thing factored now. So now in the next step, this is where we can apply what we had just talked about, our zero product principle. Okay, because we have 2 algebraic expressions. Okay, we have x plus 9, and we have x minus 5, and it's set equal to 0. So by virtue of that principle, we can take and we can set each individual part equal to 0. So we'll have x plus 9 equal to 0, and then we'll have x minus 5 equal to 0. And then your fourth step would just be simply to then figure out what x is. So if we subtract the 9, we'd have x equal to negative 9. And if we add the 5, we have x equal to 5. So x equal to negative 9 and x equal to 5. And then it's never a bad idea, in your one final step, check your solutions in the original equation. All right, so our original equation, that was our x squared plus 4x equal to 45. Okay. So if we plug in -9, that gets us -9 squared plus 4 times -9 equals 45. Well, -9 squared, that'll get us 81. And then 4 times -9, that's -36. So plus -36 would just be -36, which indeed 81 minus 36 gets us 45. So that is good. -9 is indeed a solution. And if we do the same thing, we have 5 squared plus 4 times 5, just plugging in, replacing the x with our 5. So we have 25 plus 20, which sure enough is also 45. So in this case, by using, we went from here, we were given that, and we went through our steps, put it in general form, and then we factored it, and then we applied the zero product principle to solve it, and then we checked our work. So we figured out that for that equation, our solutions are indeed -9 and 5. All right, so that is an example using factoring, and we'll do one more by factoring. I want you guys to see one more example of that. If we had 9x squared plus 27, x plus 20 equal to 0. Okay, we have our quadratic equation, and the first step is already done because we're already in general form. This is our A, this is our B, and this is our C set equal to 0. So we're already in general form. So now we can go right to our step 2, and we can factor. And I wanted you to see a different one where our leading coefficient, right here, our leading coefficient wasn't 1 in this case. Of course, it's 9. And if you want to remember a helpful hint for factoring, because that's what we're doing right now, is we're going to factor. If you want to remember a helpful hint for factoring, which we'll need to apply in this case, what you want to do is you want to take A times C, okay, and then we need, whatever the product is, we need factors of the product, and then they need to add to B, okay? So this, remember this, if your leading coefficient, the number at the very beginning before, in a quadratic equation, before the x squared, if your leading coefficient isn't 1, when it comes time to factor, remember this, A times C, factors of whatever that product is, you need factors of that number, and they need to add to B. And again, that's still what we did with the previous one. We just didn't really have to think about it because our leading coefficient was just 1. So we were just taking, our C was the -45, so we were just taking -45 times 1, and we wanted factors of 45. So we were still doing the same thing. We just didn't really have to think about this concept since A was just 1. But now we have to be mindful of it because we're going to have to take, in this case, we'll have our A is 9, and then our C is 20. So that gets us 180. So now we need factors of 180. So let's start there. We need factors of 180. So let's start coming up with, I mean, we can skip 1 and 180, and we can skip 2 and 90 because they have to add to 27. So let's skip down a couple. I mean, if we did 3 times 60, that's not going to get us anywhere close. Just like if we had 6 times 30, nowhere close. 9 times 20. I mean, that gets us at least a little closer, but not quite there. Once we add them, that gets us close. But what about, because 12 would go into 180. Let's see, 12 times, that would be 12 times 15. Well, just by eyeballing it here, 15 plus 12 gets us 27, so I have a feeling that these are going to be our two factors that are going to work for us. Factors of 180 that add to 27. So let's try them out here. Okay. And now for, again, a slight change to what we had in the first one, which is why I wanted to do one like this instead of just simply putting our parentheses down and putting an X. We have to do things slightly different because of our leading coefficient not being 1. And I think the simplest thing I find is just to split the middle term. So we'll have 9x squared, and then this 27, our middle term, our b, we're going to split that using the factors that we decided we were going to try out. So that'll become plus 12x plus 15x, and then plus 20 still, equal to 0. Okay? So this is the start of our factoring step here. We're taking that 27 and we're splitting it between these factors that we decided upon, 12 and 15. 12x plus 15x gets us 27x. And then what we're going to do from here is we're going to factor by grouping. So we're going to cut this right down the middle here. Okay? Cut it right down the middle, and what we want to do is we're going to pull out the largest number we can from each side individually. We're splitting it in half. We're grouping each individual half. So if we have here, we have 9x squared plus 12x, what can we pull out from there? We know we can pull out an x because they each have an x, so we can at least pull out an x. And then 9 and 12 will each have a factor of 3. 3 would work, so if we pulled out a 3x from 9x squared plus 12x, what would that leave us with in the parentheses? 3x times what gets us to 9x squared? Well, that would be 3x. 3x times 3x get us to 9x squared. And then 3x times what gets us 12x? That would just be 4. Okay, so we factored out a 3x. All right, what's left inside is the 3x plus 4. And then over here, we have, carry our plus down. What can we pull out of the 15x plus 20? All right, we can't pull an x out like we did on the left side because the 20 doesn't have an x, so it's just going to be a number. What if we did 5? Because we can take 5 as a factor of 15 and 20. So if we pulled a 5 out, 5 times what gets us 15x? That would be 3x, and then 5 times what gets us 20? That's 4, still equal to 0. And now you can see what we did here, which is what we wanted to have happen. It worked out just like we wanted. So we have, in the middle, they each have a 3x plus 4. So we can carry that down. That is going to be one of our two algebraic expressions. So we have 3x plus 4 that they have in common. All right, that worked out just how we wanted. And then the other piece, we're just taking what's left on the outside. All right, 3x plus 5. That is our the second part, our second algebraic expression, equal to 0. Okay? So again, for the factoring step, we wrote it out, splitting the middle term with the factors that we decided on, all right, factors of a times c. We split the middle term using our factors, and then we cut the left side in half and factored by grouping. All right, pulled out the largest piece we could from each side, and then just like we needed to have happen, turns out our terms in the parentheses were the same, so that becomes one of our algebraic expressions, and then whatever was left over on the outside becomes our other algebraic expression, both set equal to 0. So now we're at comparing it to the last one, sorry. So now we're at our step 3, where we can apply the zero product principle. Our two algebraic expressions are equal to 0, so we can take and set each part equal to 0 individually. Okay, so if we subtract the 4, 3x equals -4, and then divide the 3 out. So we have x equal to -4/3, and then subtract the 5. And we'll get another negative fraction. Okay. -4/3 and -5/3. So that was our fourth step there. We were solving. And then the final step, if we wanted to go through and check our work, and if we do the math, we'll save ourselves a second. If we do the math, both solutions do indeed work in the original equation. The 9x squared plus 27x plus 20, both of them do indeed the work. I did the math on them. So these are our answers. That has two solutions for x for that one. All right. So that we'll call that good on factoring. So that's our first method that we can use for solving quadratic equations. So now let's move to our second one that we're going to look at here. All right. And this is, again, another way that we can solve quadratic equations, and it's called the square root property. And the square root property tells us if we have, and they use u, so you can think of it u, x, whatever you want to think of it as, but they used u. If we have u squared equal to d, then u is equal to the square root of d or u is equal to negative square root of d. So it's telling us the square root property. If we take the square root of both sides to get u by itself, then we end up with both a positive and a negative answer. All right, so wrote slightly more simply, if we have something in the form of u squared equals d, then u is equal to plus or minus the square root of d. All right, so this is what our square root property is telling us. All right, so first we need to have something that's in this form, and then if that is the case, u will be equal to plus or minus the square root of d. So there's a positive and a negative answer. So if u is an algebraic expression and d is a non-zero real number, then u squared equals d has exactly two solutions. So let's take a look at a couple examples here. So now we're going to be applying the square root property instead. Okay, I'll leave that there for us. We can still see it. So if we were given 3x squared plus 10 equals 517. Okay. Well, the first thing that we're going to do here is let's subtract the 10. Okay. Because again, this isn't like factoring like we were doing before, where we were getting it put in the general form. What we're trying to do is we're trying to make it look more like that, so we can apply the square root property. So be careful with that. We're working the square root property right now. So let's solve it down as much as we can. So we subtract the 10. That gives us 3x squared equals 507. And then let's divide the 3 out. So then we have x squared equal to, that's 169. All right, and now see where we are here. This looks a whole lot like this. So let's apply the square root property now to this x squared equals 169. So if we take the square root of both sides, okay, because we'll have, by doing this, the exponent and the square root, they'll cancel each other out, so we get just x. And then on the right side, we'd end up with plus or minus the square root of 169 following our square root property up here, because we have it in this form. We solved it down to that form, and then we applied it, so now it's equal to plus or minus the square root of, in this case, 169. And in this case, 169 comes out to a nice clean number. So when you take the square root of 169, that's just equal to 13. Okay? So we have x equals plus or minus 13. So we have two solutions for this equation. And let's take a look at another one here. And again, we'll do our square root property. So we have 4 times x minus 5 squared equal to 24. All right, let's start solving it down. Let's take care of that 4 first. Definitely, let's do that first before. Don't try and do any square root of both sides yet. Get rid of that 4 on the outside first. Divide that out. So that gets us, we're left with x minus 5 squared equal to 6. And now we can take the square root of both sides because we're good to apply the square root property. Because remember, u, whatever u is, it's just an algebraic expression. Doesn't have to be single like x squared, or, I mean, in this case, it's just x minus 5. It's just an algebraic expression. So once we're at this point, we're good to apply our square root property. So we can take the square root of both sides, and then we'll just be left with x minus 5, and then remember, by virtue of the square root property, we get our plus minus there. So plus or minus the square root of 6. And I think we can just leave the 6 under the square root since it's not a nice clean number. We'll just leave that alone. And then all we have left is to add the 5. So we have x equals, and be careful here, don't get tempted to, we're not adding it to, we're not adding the 5 to the 6, to make it square root of 11. It's not being added anywhere to the square root of 6 is a separate thing. We're not directly adding it to that. So just put the 5 out front here, and then we still have plus minus the square root of 6. So that is our final answer for that one. So we'd have x equals 5 plus square root of 6, and x equals 5 minus the square root of 6. If you were asked to approximate it with decimals. So we'd have, again, 2 solutions because of the plus minus. All right, so that's using the square root property, and I think we're going to stop this lesson here. So far we've talked about what a quadratic equation is. Again, a second degree equation. All right, highest exponent is a 2. It's in the general form ax squared plus bx plus c equal to 0. So we know what a quadratic equation looks like. And then we went over solving them using both factoring and the square root property. So remember factoring, remember that zero product principle. All right. If we have it set equal to 0, we can set each individual one equal to 0 to solve. And then the square root property, when we have something in a form like this, and we can take the square root of each side, so that just becomes u, but then don't forget the plus minus, because we'll have 2 solutions. So factoring and the square root property. So we have 2 ways that we can solve quadratic equations so far. 2 very useful methods. And then we're going to add to that in the next video with a couple more. But hope this one was helpful, and thank you for watching. And as always, be sure to check out the channel for more algebra lessons.